Search for the phrase cloud deployment models and you'll end up getting articles that reference public, private, and hybrid clouds. In some instances, they'll use the word multi-cloud as well. While that's accurate, I really wanted more depth and nuance to the topic. The public, private, and hybrid cloud terms aren't prevalent in many of the discussions I have with my clients. This is a pretty vast topic, so I hope to do it justice. Please note, this is by certainly no means authoritative because there are many ways you can view and categorize the various ways to deploy your systems into the cloud. Before we get into cloud deployment models, I'd like to start with a brief primer on horizontal versus vertical scaling because I'll use these terms a lot in this video. Simply put, vertical scaling, take your web, app, and database layers of the environment, picture them on top of each other, and remember there are limitations when sharing the workload at the application and database layers of the environment. Let me pick on Microsoft SQL Server for a minute. Clustering a Microsoft SQL database was really about it failing over when one of the two servers went down. It wasn't designed to share the load amongst two machines. Said differently, original Microsoft SQL clusters were for uptime and not for processing more work. To scale this environment, because you were relegated to a single database server at a time, your options were to add CPU and RAM to the same single server. So that server got bigger, and we represent this as being vertical. You cannot easily scale it to a second machine, which is what horizontal scaling refers to. Also, Microsoft has long addressed this issue, and other database vendors struggled with this as well. And so I only use it as an example, not to pick on Microsoft. App servers suffer from the same issue. If the logic isn't built into the application, enabling it to look for other instances to process, you end up having to build massive single instances of servers. Let's move on to horizontal scaling. Imagine you can take these original three tiers and you can have an array of these devices going left and right as wide as you'd like. Each server can literally be garbage because if one of them fails, they can be kicked out of the rotation and the load is split amongst the remaining working servers. We've done this fantastically at the presentation or web layer forever, but when you're able to do this at all three layers, you start to move in the direction of being truly elastic. So let's move into what the video was really about, which is the different methods of cloud deployment we see. So I'd like to outline all the options to us, but some housekeeping. I'm going to lump some things in here that aren't considered cloud at all, but they're still very relevant to the discussion. Also, I'm going from oldest to newest technology. And then lastly, I'm not going to deep dive. This is a super technical topic, which would be hard to cover in the 10 minutes we have together. So don't laugh, but I'm going to start with option number one, which is mainframes, which you would think is the opposite of cloud. But in a manner of speaking, it could be argued that mainframe is the original cloud, but without the internet to make it universally accessible. Let me explain. You had massive horsepower concentrated in a single group of machines that can be partitioned to run different functions. Folks from around the company would connect to this using fairly low-powered terminals, and all the data resided in a single area. Take a mainframe, give access to it over the internet, and it's cloud. Just really old, hard to maintain, and expensive cloud. The second deployment method is client-server. Again, it's not cloud, but it's been adapted to the cloud. The easiest way to outline client-server is to think about any desktop application you use. It's an executable file that runs on a computer, and its data is typically stored on the same computer. There's no web app and database layer to it, but it's still a staple for many businesses. In the healthcare field, many applications are still client-server, with software publishers trying to offer hosted versions of these applications. To enable it for the cloud, you basically are allowing folks to log into a terminal server, which presents the application screen to you almost like streaming a video of the screen. If you've ever used LogMeIn, or if you've gotten remote IT support where your keyboard and mouse are taken over by a technician, it's very similar. So the terminal services are how these are deployed into the cloud, but the application scaling itself is a bit tricky. To scale, the application is run on one machine and maybe the database on another. For scaling, you just add more RAM and more processors. Most of these software providers, I imagine, are trying to recode their app to run into the cloud using a more modern method. Number three, three-tier architecture. This was the happening thing when I started in IT in the 90s. There were web, application, and database tiers, and you can use any web browser to access the app. The web layer was presentation, the application layer processed the business logic, and the data was stored in the database. Many of these applications stored vertically, which means you would get bigger servers as the application in the database tier grew. In the web layer, we had load balancing, which allowed us to round robin those requests. And that piece was actually horizontal. Moving on to method number 4, microservices-based architecture. Since this is new and just different than what we're used to, it may take the longest to explain. If you're familiar with the way an API works, you can quickly grasp what microservices-based architecture is. Rather than writing a lot of code into a monolithic single program with all the components in one place, you build containers for each application. Each container contains all the libraries needed to execute a specific aspect of the software in a very single task sort of way. Let me do a simple example. You build an application for your online store. You have a shipping microservice in your application which would receive an address and a weight from an invoicing microservice and then compute the shipping and estimated delivery times and hand it back to the invoicing microservice. Let's say it's a holiday and the invoicing microservice is getting clobbered. The orchestration and scheduling app, which would fire up more invoicing and microservices, would allow the system to know, hey, there's 2 of me now, and you're free to request invoice creation from me. As this increases, the load on the shipping microservice will increase too. Scheduling and orchestration will say, hey, we need to spin up another instance of this shipping microservice until I notify you otherwise. If the app is truly elastic, it will note the decrease in requests after the surge and then turn off those extra instances, meaning you're handing resources back to the infrastructure. If this is public cloud, you are no longer being charged for this computing resource. The takeaway is you've broken your application into small sections, each responsible for processing very specific tasks and being always available to provide the computation when it's requested of it. This model is very easy to scale horizontally, meaning you can scale the instances left and right of that instance with low-powered containers and then just share the compute load over those new instances. You don't need massive CPU and RAM to single instances, which is what we did when we scaled vertically. Number 5, serverless is a computing method that just runs code. You give it code, it'll execute your code, and it'll output the results to wherever you want it as many times as you ask. In the serverless world, major players would be the likes of AWS Lambda or Google's Firebase. You can set up your code to automatically trigger from other cloud services or call it directly from any web or mobile app. Serverless really shines if you have a process that kicks off, needs a lot of horsepower in small intervals, and the results are handed off to some other infrastructure. I think this is probably the trickiest to explain, and so I'd like to give a real-world example of how this could be used. Let's say you run a site where you take a rectangular profile picture and you spit it back out to end users with rounded edges, which is incidentally a service I've used because my Photoshop skills are garbage. So you would have a simple website, folks would upload their rectangular picture to the server. To convert this, you would need some code to run a bunch of computations and convert the image. It may not be worth having an entire environment built out to execute this code. They may sit idle for long periods of time. So you have this very simple website which would take the file and then push it to a serverless instance that would crunch it, round the corners, and then place the resulting file in some online storage with a download link presented to the client. The total computation and processing of that function could almost be free, especially when sent to some massive infrastructure that processes code all day. So you're not occupying any compute online 24 hours a day, but just tapping a service that can execute your code like a utility. So let me wrap this up and pray that I haven't made this more complicated than it needs to be. But when looking at these deployment models, one may sound better than another, but they are really the continuum of how our application delivery technology is developing. The goal of this video is not to promote or push an angle, since changing deployment models without changing the code is not something you can aspire to. You are relegated to the cloud deployment model that you have based on how the code is written. You can choose to code all new applications using something modern that runs on these newer cloud methods, but you can't simply take your existing application and deliver it through a cloud technology that can't serve it to your clients at a reasonable price. I thank you for joining me this week for this explanation, and I hope it sheds some lights on the various ways applications are delivered via the cloud. Take care.